In this video, I'm going to go over the Profiler SRV safety valve test software for SofTek engineering. The first thing that we're going to do is we're going to look at the accounts. In the accounts, we can create new accounts for individual users or one account for an individual company. So we can go into accounts, enter the password administrator, click anywhere outside of that, and it'll bring up different usernames and passwords that have been entered in. If I want to create one, I can create one, George, and his password is blue, and we're going to give him a permission of 3. 3 means he's going to be more in a field service environment. Permission of 1 is going to be more of a production type environment. So if you're in the field service world, you can enter in a permission of 3. If you want to change your password to be the administrator, you can do that here. Note is if you do change this password, if you lose that password or forget it, we'll have to reset all of this back to no users and no passwords. They'll have to be re-entered in. Okay. So at this point, you can then hit stop, say overwrite, and that will create a password and user for anyone in that case. The advantage of that is that it gives you the ability to keep track of who used the system last. There's a log sheet, shows you the last person to log in, so if anything goes missing or broken, you have an idea of who to contact to make sure what happened or where those parts may be. Okay. Here we're going to log in, have my password. Down here at the bottom we have today's date, time, what version of software we're using. Last time it was updated, it was in April 2025, and the calibration date was 2/22/2025. So this will keep track of the calibration. Once you get a year into this, you will get a warning that will pop up that says calibration is due in 30 days. It'll also warn you that if you're past due in calibration. So this is so you can be under traceability and calibration. So keep an eye on this every time you log in, but there will also be a warning of when the calibration is due that can be sent back in. Okay. So now we will go ahead and we will hit log in. You can enter, or touch screen, you can hit the log in. Okay. Now, first thing we're going to do is we're going to go into enter valve information. And in here we have a selection of customer lists. So in this customer list I have several customers that we have entered in previously, and also locations of these customers. Now, what we can do is we can add a customer if needed. So we can add this customer for the purpose of what we are going to do. And once we hit add, it'll then be at the bottom of this list. Okay, same way with location. So that way you can come in quickly and enter the data in. So valve information is very critical. This that is blinking in red, these 6 over here, has to do with the databasing or the process of databasing of the test. What is in the set pressure over here, that is what the set pressure that is required for the test results. Okay. So that's very important in what we are going to enter in. So I'm going to go through a process of looking at this. Now, there are different manufacturers of safety valves. In this case, there's Consolidated, there's Crosby, Ferris, so on and so forth as we go down through here. And there is more information that we will be adding as we get the data for different valve manufacturers. Okay. So in this case, one other advantage you have is you can pre-enter in all of this information ahead of time before ever going out into the field. So I'm going to show you how that works. Is it's pre-entered in. I can hit recall, and I can go to the database, basically the database there for it, and I can enter that. I can go to that spot and I can recall and I can go to where that data has been pre-entered in previously. Okay, and so in this case, we have some pre-entered in data. Okay, now if I wanted to create a different test or different company, I have the ability to adapt to that. I can add in a different customer, a different location, and also I have the ability to enter and save those. Okay, so in this case, I'm going to have a customer of IPP. Location is going to be in Houston, and also serial number, tag number. This tag number is, the next one is number 29. Okay, and the job number still remains the same. So you can pre-enter in all of this valve information, who tested it. This is a set pressure of 250, and we know that the line pressure will be roughly around 77. Once we enter that in, we have the ability that it will calculate, because we know what the mean seat area is. The mean seat area is down here on the list. As we move this list down, we can find the valve manufacturer and the model or type, and as we select the model or type, it will bring in the mean seat area for us as we click on that. Okay, so the mean seat area is very critical. We have to have that to do our calculations. If for some reason we do not have the mean seat area on the list, we can also go to manually enter, and we can take the nozzle ID and the nozzle, or OD and the nozzle ID, enter that data in, and it will give us the calculation of the mean seat area using this formula. Okay, so we can still get that mean seat area. So what that tells us is, in the manual mode, this is our mean seat area, and in the automatic mode we have this same mean seat area. What it tells us is that's going to be the pulling force on the load cell. So it'll automatically kind of calculate with this much pressure. As I change this pressure, if I go to 100, that will change my pulling force that is needed to pull or lift the plug off that seat. So in that case, we're roughly going to be around 77. We do know that. We also have the ability to have different percentage of error. Okay, so as we look at our different code tolerances, we have the different code selections right here, and we also have manually enter our tolerances in percentage or manually enter in PSI. So if there are other tolerances that are different than what is in the code, you can manually enter that in, and it will select it over here. So I manually entered it as PSI, so I could say 10 PSI, and I could say minus, because it already has a minus. I don't have to put a minus here, I can put just 5. So plus 10 to minus 5 in that case. But in this case, because of the code, it's selected plus or minus 3%. If I change this to, say, 1001, that will change it to 1%. If I change this to 500, that will change it to plus and minus 10 psi. If I change it to 14 here, it's basically NA. There is no pass-fail in that case. Once I get to above 15, it will give me plus or minus 2 psi. So it's following the code selections in that automatically. So as you enter your set pressure, 250, it will automatically bring it in as percentage plus or minus 3 for you. Okay, and in this case with 77, I will pull 192, and so that's what it will help us choose the load cell that we are going to use. Once we're done, we can hit save, and that will save this information. And then this information will then be used as we do our calculations and our databasing for the future. Okay, so the next time we come to this valve, we can just hit recall, and we'll find this valve and bring it in. We don't have to re-enter this in every time. It's a one-time enter the data information. Okay, so once we have the valve information, we also have what we call the thread adapter. That helps us know which adapter to attach to the load cell so that we have the ability to pull on that safety valve. Okay, the next thing we're going to go is we're going to go into our transducer. So we're just going to go step 1, step 2, step 3, step 4 and so forth. So step 2 is transducer setup and cal. So in this case, we have a selection. So here's our load selection. I have load, I have pressure sensors, I have displacement, and I have vibration. Okay, so our load is going to be our load cells, our pressure sensors on this one. Displacement is going to do our lift or our position of the valve as it lifts. We'll see how far it lifts. We can also use this for national board in measuring the lift or the full lift of the valve. And vibration is a great sensor. It will help us pick up the simmering of the valve right before the valve does pop. Okay, so we're going to go to the load cell. Now, you could have multiple different types of load cells or ranges. In this case, we have 1,000 and 5,000 and 10,000 and a 500, and we have multiples of each one. So what's nice about the software is you could have multiple systems, and you could actually share the load cells from system to system as you have the data entered in for the max range, the offset, the span, and the shunt calibrations. It gives us our scaling factors. It also gives us the last time the valve was calibrated, the last cal date and time, the units, the scale factor, and the shunt. And the shunt is what we use to verify that the load cell is actively working. We can shunt it before we actually do a test to make sure that it's working properly. So if I have a load cell requirement, we saw that it was 192 pound pull. So that would fall well within the range of 500. But let's say I had it set up at 1,000. So if I needed to pull 1,000 or anything just under 1,000, I could go to the 1,000 load cell and I could hit add. And that would add that serial number, model number, all of that. So these are the sensors. These are my options. These are the sensors that I'm going to use, or transducers I'm going to use to do the test. So I have load, I have pressure, I have displacement or position, and vibration. Okay. So these are the 4 that are checked off. Now I can see right here that this pressure sensor shows up not calibrated. Okay, so that would be something we would not want to use. But I'm showing this as an example that will show up on our test report that the pressure sensor we used was in an uncalibrated situation. Okay, so we have all this valve or this information about each position, each pressure, each load, and each vibration sensor. Okay, so these are the ones that I'm going to choose. I'm going to go back to my 500 and I'm going to hit add, and so I know that I'm going to use a 500 pound load cell. Okay, so now I've selected my load cell, my pressure, my displacement, and my vibration. Next, I'm going to go to what we call checkout. And in checkout is where we will select what sensors we want to use for doing our test. Now, we will always use the load cell when we're going out in the field or we have to use the lift device. In this case, we have the load cell at 500. I want to also use, since I'm going to be doing it in the shop, I can use a pressure sensor. So I'm going to demonstrate turning on the pressure sensor. In this case, we have roughly about 76 psi to the valve at this point. We'll also turn on our vibration, which is our accelerometer, and also our load. Now, accelerometer and load, or the accelerometer and the displacement, are indicators. They do not or are part of any calculation for set pressure. Okay, these help us and give us indicators of the valve lifting or coming off the seat. This also gives us indication of the vibration starting when the valve starts to simmer and then when the valve pops. So these are indicators. Now, the 2 calculations we use is going to be pressure, which is either going to be in the field or in the shop environment. We're going to be needing to use a pressure sensor, or the pressure is going to have to be read and brought to us or called to us from the control room. Okay, so if I'm out in the field, I will probably not be using a pressure sensor in this case. Okay, and I may not want to use my load cell, but the or the position displacement. But the load cell is key, is everything. We always have to use that one. We don't turn that on or off. And the vibration. These two sensors are suggested that you have to use this one, and I suggest that you use the vibration accelerometer to help pick up the pop point on the set pressure. Okay, but in this case, I'm going to demonstrate all 4 sensors as they are being used in the field. Okay, so we have selected those, we've turned them on, so these are all on. We'll go to what we call system setup. Now, system setup tells us the ID of the system. So if you had multiple systems, 4 or 5 systems in your facility or your company, they would all have a different ID number. You can put a custom logo on this, so you can put your customer logo on this. And our interface box has 2 separate input 1 and input 2. So in case anything ever happened to input 1, you have redundancy built in, we can go to input 2. Our load cell has a warning light. Once you put the load cell over 110, you'll get a yellow light. 120, you'll get a red light. So we don't want to overrange our load cell when we do our test. We have a feature in the Profiler SRV called Auto Start, and that is going to be where the test can automatically start while you're using the pump to start lifting. You can also have the test automatically start, so you're not starting the software and using the pump. The auto start will start at, in this case, 10% of the load that it will take to lift. Now there'll be a calculation I will show you here in a minute what that load will be when the test will start, and we'll show you that. Okay. For the hydraulic ram area, this is a number that we'll enter in. You don't have to enter this in. And then also for our accelerometer, we have a calibration that we enter that in. Now, factory, we have where are you located. So this will be also on the printout. So the printout will have all this information about where you're doing the testing or the factory of the testing the results. Also the VR number and the test only number. So you can put the 2 numbers in and the expiration dates. Okay, so this will also be on all the printouts, so your customers will know your number. So you put that in one time, or when it comes back, or when you're ever having to redo your calibration or your expiration date, you can re-enter this date. And so in this case, it expires 3/28/2025. Okay, so in that case, this has not is overdue. Okay, so I'm going to show you that example of being overdue. Okay, now the next thing we want to do is we're going to go into what we call calibration. Now you'll see a blinking light up here. This screen, you don't have to enter anything in here, and don't worry about this blinking light. This is another area where we do what's called calibration. We use this screen when we calibrate the load cells. And if a customer would like to purchase traceable calibration load cells, they can actually calibrate their own load cells by using this software and the rig to do the pull. Okay, so this screen is normally not used. The only thing that we come here is to check our load cell, and we'll push this button here for shunt. Now we want it to be between plus and minus 0.5%. And we see that we're about 0.25%, so that means it passed. That means our load cell is accurate and is ready to go. Okay, there's nothing damaged or any problems with our load cells. So once we do that shunt, that's the only thing we do on this screen is we come in here and shunt this before we load it and put any pressure on it. Okay, so as we leave this screen, we'll leave here. We have now entered the valve information. We have went in and verified our calibration check sheet, and we can also gone in here, and once we've entered these in, this will be ungrayed out. So we can now go into here and run the test. So we're going to run 4 tests. Okay, one, we're going to demonstrate the as found. Then we're going to test the next 3 for the average of the 3. Okay, so we're going to go into test, As we come in here, we'll see that we have the load, we have the pressure, we have the lift, which is your displacement, and we have the vibration. Okay, this is all the valve information come in that we pre-entered in. This is our error, plus or minus 3%. Any notes you want to go here. And it says to use the 500-pound load cell. So that's what we have entered in. We've put the load cell in the rig, and we are ready to go. Now, roughly around 193, if we have the line pressure of 76, about 193 is where, if this has been set correctly, is where we would expect it to lift off the seat. Okay. Now, when we talked about auto start, that's 10% of this number. So once our load cell hits roughly 19.3, so once this load cell here, this number hits 19.3, you will basically start to see the test start running. Okay. Now we have 45 seconds here on the test on the scale. Now you can change that to as long as you wish, but 45 seconds is usually a pretty good number to be able to pump and lift. Now, with the Profiler SRV, we have small hoses, small diameter hoses, so that doesn't take a lot of volume, and the pump we use is actually a very large pump in the respect of flow. It's small in size, but a lot of flow. So it doesn't take too many pumps to actually lift the valve. It's much easier to do the testing. Okay. So at this point, I'm going to start doing the first test, and I'm going to start pumping. Okay. And now you're going to start seeing the load here lift. Now you see the blue load up here in the corner, and it's starting to move up a little bit. I'm just doing this slowly so that you're going to notice once it crosses the 19-20 threshold, now you see the test starting to run. Okay. So then I can lift my arm, and then I can give it a good, nice, even push, and then I can release that. I'll hit F2 to stop the test. When I hit F2, it will auto scale for me. Okay. Now what I want to do, so I can see this clearer and wider, I'll go to my slider. And this is a vertical slider, so go to the center one. Click there, and you can slide over to about the edge of where the load cell dropped right off, just to clean this up. We have cursors. We have a blue cursor, which is the load, and you can see the load cell right here. That follows the blue load cell. Okay. All of our sensors are color-coded, so we have a blue load cell with blue cabling and a blue connector. We have a red pressure sensor. Okay, and you can see it follows the red pressure right there, and that will follow and track that. Okay, we have a green one which will show us our lift. Okay, and that's our lift. That's how much we lifted, 9/1000ths of an inch. And we have our accelerometer at this point. And so what I normally will do is I will put the accelerometer right where it starts to increase in vibration. That increase right there in the corner is where it's starting to simmer. Okay, so I can then come to the load cell. The next bump with the load cell will be, which you're going to see right here, you'll see the change in the load. This is a very low pressure, and it's also a low volume type test system. So we can catch the bump right there, and we can put the pressure right on top of the load cell. And it shows this is a 250 set pressure, and I can zoom in on this just a little bit tighter to see this a little bit clearer. And you can see now exactly where it started to simmer. So it started to simmer here on the accelerometer, the vibration. And as the vibration goes up, we can see where the load cell changed. And where the load cell changed is where our set pressure is set. Okay, so we can see the change in load. Our pressure is reading here. We had 76.23 exactly. So when you can read the pressure itself, especially in the shop or in your facility, it's always best to use the pressure sensor, and then we get a good reading on pressure. And then you'll see the load, and you can also see the lift. So here is the error. We're allowed plus and minus 3%, and we are low by about 1 psi. Okay, in our set pressure. So I will hit save. Okay, at this point, that's our indicator, and we have saved that. Now, that will be our as found. Okay, I'm going to go to the database right now, and I will show you as we go to the database. Here's our first test. So here's our test. Here's the date. Here is our job number and our tag number. And this is the first valve tested on this. So we can highlight this, and I can go to print review. It will bring up the print review. I can open this up for a little bit wider, and you can see here is all of our valve information. Okay, here's our location, our address, phone number, VR number, due date, test only, due date. Also, we have our customer information. We have our lift, our additional information. We have our section. Okay, have got this section here. Opening load was 192, line pressure, set pressure, lift achieved, and our error was 0.38. Okay, so this is our as found number, and we will also keep track of it, test 1. We'll go test 2, test 3, test 4. Now when we do our averaging, we haven't averaged three tests because we haven't done 3 tests yet. So we have the average of the 3. Okay, so once we get a third one, in certain cases where the as found passes, we could use that as the one of the 3. But in this case, we're going to go 4 just to show the example of 4. We're going to show you the as found and the average of the last 3. So if I did 10 tests, it will average 10, 9, and 8 is my last 3 in consecutive order. Okay, this is our traceability. So when it shows you the valves are traceable, it shows you the calibrations. Due date talks about our shunt right here, where we were at with our shunt. And it will also give you the printout of the graph, and you can see I show you the zoomed in portion of that. Okay, so what you save on the screen is what will be saved on this test result. Okay, have notes. We have tested by and date and inspector, and also date that can be signed with any of the notes here. Okay, so we are now going to add. We're going to run 3 more tests. And we're going to do 2, 3, and 4, and then we'll give you the averages as we do this. So we'll come back after we've done the 4th one. We'll do the next 3 consecutive, and we will show you the results here. Okay? We'll exit back out. We'll go back into test, and we are ready to start doing our lift again. Okay? So I will slowly get the load to start. Once it gets above roughly 20, the test will start. There it started, and now I can lift it and also give it a nice smooth movement. Okay, I'll hit F2. F2 does the stopping of the test. Once it stops, we can then again grab the middle slider, and I can bring the slider over to the edge right here, and then I can bring my cursor. I'll bring my load cell right over here to where the indicator is of the load. I'll bring the pressure and put it like basically right on top of it. There. We can see our total lift. We can see where our total lift was at, and we can see right where it started. I moved this one a little bit slower, so you see a little more gradual on the load. You can go faster or you can go slower, but this is a little bit more gradual in that respect. So we have this one set. So if I had to make a change now, if I needed to adjust, I could say I adjusted this so many turns on the nut, and I did it either clockwise or counterclockwise, and that'll keep track of that on the test report. So if I'm doing adjustments, I can do adjustments, and then I can do the set, and I can keep track of how many of those adjustments, either clockwise or counterclockwise, and which direction that was done at. And it'll be on set, and that will be test number 1. Okay? So as we do that, it'll advance to test number 2. So I will hit save, and this is the set pressure here on our test number 2, okay? So we've saved that. I will come back and we will go right back to lifting. I don't have to reset anything. The graph will reset itself. I'm just going to watch the load cell. So you'll see the load cell starting to lift here. Okay, I went extremely fast that time to show you a little bit different. I will zoom in on here. We went a little bit higher, okay? But even though we went faster, you can still see the load right there as it switches slopes. When that load switches slopes, you still have the ability to capture that, okay? And there's our position on the green, and then this is where it started to, right there is the flat where we have our standard vibration, and then right there is the indicator of simmer. That's where it starts to simmer, and then once it popped, you see the slope change in the accelerometer also. So now we have the ability to see our load right here, and we have an indicator of or minus 0.28, okay, just percentage low. So I will hit save, all well within tolerance. We will do one more. I did this one even a little bit faster to kind of show you. We zoom in so we can clean that up a bit. And again, as we look at this, our load will come over here and you'll see the load is right there. You can see that slope change. As that slope changes, that's where the valve lifted. That has less force on it in that respect, so it's being lifted. So that load changes, then we put the pressure on top of that. And there's our position is up here, and our vibration started to vibrate, simmering roughly right in that area, okay? And so now I can hit save if I want to put notes, test 3, something like that, and we can see we have a green light. If you notice, as I'm dragging the red line, if I have it here, this is calculating my pressure, so you'll see my pressure line over here. And as that is being adjusted, it automatically does the calculation for me so we can see that, okay? Now, if I did not have the pressure sensor, you would have to manually enter in the data or the pressure right here for the testing out in the field. So once you wouldn't have the red line would be off, okay? And you'd probably have your load and your vibration on. You may not do your lift position or your pressure, but I recommend doing the vibration, and you have to have the load, okay? So you'll have 2 lines rather than 4, but I'm showing you all 4 lines. If you don't want to show a line, you can go ahead and you can turn that off, okay? So let's say I don't want to show lift in this case, okay? So I can, and if I want to graph this a little bit different, bring it over to here, I can graph that a little bit different. If I want to change a little bit of my numbering here, I can go to 0 on my vibration, and I can bring my vibration up a little bit here. I can change its scales here to 112, so now I have a little bit more indicator of my accelerometer as it's moving up through there, okay? But I still have my position and my load cell, and they're basically, when you do it in the shop, you'll put where the pop is at and the pressure at the exact same spot, and that's the way you know the exact pressure at what load you are at, okay? So I'm going to now hit save. Once I hit save, I can now go to my database, okay? Once I go to my database, you will notice here is my tests. Test 1, Test 2, Test 3, and Test 4, okay? They're all done today. Today's date was 5/26/2025, and this is my tag number, okay? So we saw Test 1 previously. I'm going to go to Test 4, and we're going to show that. So I'll zoom in so you can see it a little clearer. Now, we have all the valve information of this specific test for Test 4, which is this test. And if we made adjustments to the spring, you would see the spring adjustments and clockwise or counterclockwise here. But you can see the as found was 249.06. The average of the last three was 249.04. So our error was 0.38 for the total. So that is the pass of the last three. Okay? Now if I had additional ones down here, it would also average the last three tests only. Okay? So with that, you can see that I turned off the lift. It didn't show the lift here. So I could show, and I could give this one test right here. It shows all the test results to the customer. Some customers will accept this as the one test or one graph, one printout. So if they want to see all of those, what we can do is we can add them to this list, add them to this list, add them to this list, and add them to this list. So now it will put that in the order. I will hit what's called combine. Okay? So I can combine those tests into one. If I do hit combine, it will now put the test of those combined in one PDF right here under the test report. So if I go and look at my test report under view, it will bring this up. I'll open it up so you can see better. So this will be test 1 we did, test 2, test 3, and test 4. Okay, so we did it in the order that it was done. But some customers may want to see the test first. So I'm going to remove these, and I'm going to do 4. I'm going to put 4 first. It will do it in this order. I'm going to put it in reverse order. Okay? And once I do it in reverse order, I can say combine. And once I hit combine, it will overwrite this. Now when I come here and view it, as we come back, it shows our number 4 test, okay, which is our number 4 test. You'll see right here and right here is the top of the report. So that's the very first one, and then this would be test 3. You can see right here, test 2, and test 1. So that gives the customer all of the tests. He can manually calculate the opening load and the line pressure with the mean seat area, because the mean seat area is right here. He can do his own calculations to make sure the calculations are done, or to verify that it was done correctly and calculated correctly if the customer would like. Okay. So with that being said, we have the ability of doing that. We also have programmed in here the Calpine report. So you can come to the Calpine report. That will bring in the header. You can enter the header information. You have 7 pages of information that you can enter in. Page 2, page 3, page 4, page 5, page 6, and page 7. This will also, when you get done, you hit save, and it will put it here, and we can add that to the list. So you have the 4 tests and a 7-page report if you're doing work for Calpine. Okay, so this is the Calpine report. Now, you can also select them all, and you could also print them all right here at one time if you wanted to do individuals. But if you want to email, it's easier to email one PDF and also one test report for everything. So it's a quick way of doing that. We also have the ability to use Explorer or Calculator. Those are already on here, so I can hit Calculator. That'll pop up the calculator on the computer, and you can use that to do any calculations you may need also. Okay? With that being said, we'll go back here. Procedures. If you have, say, procedures that you wanted to enter in or put on your computer for your company, for your customer, whatever it may be, there's a procedures folder. So I could select this, and I could come in and I could say, view that. So I can bring in that section there, and this will bring in all of that information for that section. Okay? Or it could be procedures that is customer specific, on how you're assembling, process, drawings, anything in that respect. You can put that here. So this is up to the end user or the customer who's using this to put their customer procedures in, and that way, if an end user wants to see what procedures, you can come here, quickly highlight it, and print review it, and it will show up of what you're using as far as, you know, here's the code for the boiler and pressure vessel code. Okay, so here's an example of doing that. So you can do that as, and this is somewhere where you can put that. It's in the program files, SRV, procedures, and you just drop every PDF into that folder right there called procedures. Okay. Another thing we have is we have seat leak. So we have the seat leak capabilities with this system. I'm not going to demonstrate that at this time. It's more in our training program. So if you want a bubble counter, we have a bubble counter that will do our seat leak testing, and it will basically count the allowable bubbles you're allowed per size. So you have the API 527 with air, with steam, with water. The bubble counter will also do water, count of drips of water, and also the other test method with air in that respect. So all that valve information will come in here. We have the test information here, and then we come over here, we have additional information we can enter in for the procedures. Okay, so as we do that, we'll come in here with air, with any of these, and then I'll come to step 2. Step 2 will show me the pressure that's in the valve itself as we do it. So we need to set this pressure between 224 and 230 for the range, for the 90% in range. So basically 225 is the number for 90% of the pressure. So we can come in and set that pressure to 225, read it, and we can hit start, and that will start the counting of bubbles over the amount of time that it is allotted. So you can change the seat leak time here, the stability time, however long you want that, and then you can run the test. Once you're done, you can hit save and exit, and it'll create a leak test report that we can add to this test report. So this will count bubbles in that respect if that is needed for your leak detection. Okay, so this is another portion that we have as an option. It's not comes with the standard system, but it is an option. Okay, we'll now exit out of here, and we have basically gone through the software in detail for what we are demonstrating for the Profiler SRV. I appreciate your time, and hope you enjoy your new system with the Profiler SRV software. Thank you.